R-CADT is pleased to invite you to participate in the course. Parallel and Distributed Optimization. With emphasis on artificial brains, Bender's partition theory, Lagrangean relaxation, cross-composition, and asynchronous parallel optimization. The course provides the student with the knowledge, computer programs, of multiple types of algorithms, based on advanced optimization methodologies, all of them supported by parallel thinking. From real-world practice to academia. R-CADT, Research Center for Advanced Decision Technologies, is a division of Hypothalamus Artificial Intelligence Incorporated, USA, oriented to research, technological development and innovation, RAND+I, in high-complexity mathematical modeling, with an emphasis on optimization, whose mission is to bring its benefits to humanity, which involves enable professionals to successfully apply optimization technologies in their organizations, and to be entrepreneurs and mentors of new companies, spin-offs, that bring the benefits of optimization technology to society. Currently, the central topic of R-CADT's research is augmented artificial intelligence and more specifically artificial hypothalamus. To fulfill its mission, R-CADT has created a set of courses in advanced mathematical modeling that are aimed at supporting professionals interested in receiving applied training, at the state-of-the-art level, based on the experience capitalized on over 50 years executing engineering projects and development of analytical software. Most of the things and processes that humans use have been totally affected by technology, which has opened up to the human imagination producing previously unsuspected results. Mathematical modeling should not escape this process, starting from discovering the mathematical foundations that serve to establish the laws that govern physical, industrial, economic, biological, health, and social laws, and with them build mathematical models, and increasingly powerful calculation algorithms. Nowadays all knowledge and technology are available to develop a higher-level artificial intelligence, which emulates human intelligence in any type of human organization, and can be called the artificial hypothalamus of the organization. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. Research, technological development and innovation at R-CADT can be grouped into disruptive modeling methodologies, large-scale optimization algorithms, mathematical modeling using cognitive robots, and highly complex mathematical models for end users. Mathematical programming, also known as optimization, involves using mathematical models to find the best solution to decision problems by optimizing a function, such as profits or costs, subject to various constraints. This powerful technique is applied to complex systems for planning and allocating resources in fields such as economics, engineering, and business. Hai is the creator of the concept of artificial entrepreneurial brains, which is based on the development of parallel thinking, when a complex system must be analyzed. Based on algebra as the core of the process, the evolution of algorithm-oriented mathematics can be summarized in the following stages. Deterministic optimization and relational algebra. Predictive artificial intelligence, machine learning and advanced probabilistic models. Optimization under uncertainty, stochastic optimization and robust optimization, and artificial brains, strong integration of artificial intelligence and mathematical programming. This evolution goes hand in hand with the power of computers, which have migrated from a single process to millions of processors, and from monolithic modeling to distributed modeling, generating different levels of analytics. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus of the company is obtained. This is how the human brain faces reality. Multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by optechs, using the models that traditionally make up a decision support system. The concept of artificial hypothalamus can be applied to solve real-life problems from multiple points of view. In the diagram, the artificial hypothalamus coordinates models corresponding to the multiple problems faced by a company, organized from the point of view of its administrative functions. Another point of view is the spatial distribution of the problem. In this case, An artificial hypothalamus is presented for an agro-industrial company that has multiple facilities, farms, concentrated food factory, meat products factory, and stores in the food market. The entire relationship between the optimization models is stored in the expert system. The new way of mathematics is directly related to the parallel thinking, and today it can be said that like paper-based math, sequential mathematics for single-processor computers will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Parallel thinking. Like paper-based math, sequential mathematics for single-processor computers is dead. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed.
Objetivo y estructura.
Aimed at professionals, engineers, mathematicians, physicists, consultants, economists, data scientists, software developers, etc., who require and/or wish to know mathematical modeling, advanced analytics algorithms, related, among others, to the implications of Industry 4.0 and its relationship with the process of evaluating the technical economic impact of the decisions that are made. This continuing education program strengthens the analytical skills and professional criteria of the participants, so that they can exercise, share and/or supervise, with propriety, the professional functions in accordance with the state-of-the-art of the methodologies and technologies that support the digital transformation of the companies. The course is useful for graduate students who want to become professionals applied to highly complex mathematical models, with an emphasis on methodologies and technologies for large-scale optimization problems. It is also useful for those who are doing theses or research projects related to optimization applied to complex problems. Mathematical methodologies. Mathematical methodologies correspond to the scientific foundations for implementing mathematical optimization models. Specific objectives. Training in fundamental methodologies to support modern mathematical modeling. To train so that the mathematical modeling of industrial and business processes is a generator of real socioeconomic wealth frequently used in our society. Understand that optimizing the use of resources is the scientific basis of sustainable development. Learn about systems and industrial market modeling. Learn the fundamentals of modeling real problems based on the integration between mathematical models and data models. Information technologies. Computer technologies correspond to the computer tools available, freely or commercially, to design and implement solutions to problems in social or industrial organizations. Specific objectives. Learn how to implement solutions applied in the real world by making use of the modern computer technologies available for the algebraic modeling of industrial and business systems. Present and manage live tools used by large companies to solve their optimization problems. Understand the state-of-the-art of optimization and its relationship to smart computing. Know the available technologies, as the principle of basic knowledge to be able to solve, in reasonable times, problems with millions of variables. Know the fundamentals that must be had for the assembly of models using the most effective technologies. Mathematical methodologies. Mathematical methodologies correspond to the scientific foundations for implementing mathematical optimization models. Specific objectives. Training in fundamental methodologies to support modern mathematical modeling. To train so that the mathematical modeling of industrial and business processes is a generator of real socioeconomic wealth frequently used in our society. Understand that optimizing the use of resources is the scientific basis of sustainable development. Learn about systems and industrial market modeling. Learn the fundamentals of modeling real problems based on the integration between mathematical models and data models. Project. If the student wishes to carry out an optimization project during the course, they can indicate this to the scientific director. If accepted, the advice for the execution of the project will have a cost equivalent to 25% of the cost of the course. Theme plan. The course is guided by the book Artificial Hypothalamus and Mathematical Programming 4.0 for Industry 4.0 Cyber Physical Systems. It concentrates on the theoretical part of the book. The book presents a holistic view of applied mathematical programming, starting with the theoretical foundations of classical optimization and ending with the implementation of highly complex software solutions according to current technological principles. According to the state of the art, the following are studied: artificial brains, parallel and distributed analytics, mathematical modeling, parallel computing, the basic algorithms, and large-scale optimization theories. The following are the parts of the book included in the course.
El libro, Guía de Cursos en R-CADT, tiene 5 partes.
Part 1. Mathematical Programming and Cyber-Physical Systems. Presentation of the mathematical foundations for the solution of optimization problems. It includes the economic interpretation of optimization models, and the MPEC, mathematical programming with equilibrium constraints, problems. It also briefly introduces the different formats of optimization problems, and the algorithms to solve them. Theme Plan. Artificial Brains. The Future, Mathematical Programming 4.0. Parallel and Distributed Analytics. Fundamentals of Optimization. Economics, Fundamentals, and Optimization Technologies. Part 2. Large-Scale Optimization Methodologies. Teaching of the theoretical foundations of large-scale optimization, with emphasis on atomizing problems to solve them in parallel computers, and/or in computer networks. The objective is to present the integrated vision of real-time distributed optimization, as the mathematical way to model the cyber-physical systems of Industry 4.0. It is characterized by the integration of multiple algorithms, which continuously cooperate to solve the problems of a multi-agent system, independently using the parallel computers of the agents, and sharing information to cooperatively achieve an optimal solution. This approach is constructed using the fundamental theories of partition, and problem decomposition, Benders, Lagrange, Danzig-Wolff, cross-decomposition, and others. Theme Plan. Mathematical organization of an artificial hypothalamus. Parallel optimization as an artificial neural network. Expert optimization systems. J.F. Benders, theory, variations, and improvements. Stochastic programming and risk management, fundamentals. J.F. Benders, dynamic and stochastic theory. GDDP and GSDDP, theory, implementation and applications in the electricity sector. Lagrangean relaxation and Danzig-Wolff decomposition. Cross-decomposition. Stochastic and dynamic theory. Other methodologies. Generalized disjunctive programming. Bi-level optimization. Subrogated programming. Primal dual subrogate algorithm. Mathematical programming with equilibrium constraints, MPEC asynchronous parallel optimization. MBD, multi-Benders decomposition. Autonomous, real-time distributed optimization. Part 3. Integration of mathematical programming and artificial intelligence. Presentation of a new vision of mathematical programming, Mathematical Programming 4.0. Structured mathematical modeling, standardization of the formulation of mathematical models to make the algebraic formulation independent of optimization technologies. This makes it easy to migrate mathematical models between multiple optimization technologies. Robotization, making use of artificial intelligence concepts, to capitalize on the lessons learned in expert systems to facilitate the construction of the mega models of the future. Theme Plan. Relational databases and mathematical programming. Structured mathematical modeling. Tutorial, an example of structured mathematical modeling. Expert optimization systems. Cognitive robots, intelligent algorithms that build advanced analytical algorithms. Optex expert optimization system, a cognitive robot for mathematical programming. Advanced predictive analytics using mathematical programming. Applied teaching of the programming of highly complex mathematical models. To do this, an ALMS, algebraic language modeling system, optimization technology is used, like GAMS, AMPL, or other, and Optex optimization expert system supported by RCADT. Theme Plan. Fundamentals of optimization technologies. Mathematical models and data models. Structured mathematical modeling, case, electricity and gas model. Optex Modeler I, Lenguaje Algebraico de Base de Datos. Optex Word Excel. Optex Modeler II, Advanced Services. Feasibility Analysis. Parametric Optimization. Stochastic Optimization. Modelos Deterministicos. Optex ALMS, Advanced Services. Math Heuristics. Disjunctive Programming. Bi-level Optimization. Optex, Stochastic Programming. GAMS, Large-Scale Optimization Technologies, GSDDP, GDDP, PDS, MBD Optex ALMS, Large-Scale Optimization Technologies. Optex ALMS, Asynchronous Parallel Optimization. Optex, Artificial Hippocampus, Cutting Planes and Convex Hulls. Optex, Artificial Hypothalamus. Considering the current evolution of quantum programming, R-CADT has included the topic Optex Quantum AI, Quantum Computing and Artificial Intelligence, which presents the advances of the RCADT in this field of R+D+I. Quantum computing and artificial intelligence are two transformative technologies that, when combined, create quantum AI. This integration leverages the unique properties of quantum mechanics, such as superposition and entanglement, to enhance AI's capabilities to solve complex problems, optimize processes, and analyze massive datasets. Quantum computing operates on qubits, which can represent multiple states simultaneously, unlike classical bits that are binary, 0 or 1. This allows quantum computers to perform calculations at exponentially faster speeds, making them ideal for AI tasks such as machine learning, optimization, and data analysis. Optex Quantum AI is the version of Optex that produces algorithms that can be solved on quantum computers. It inherits all the AI features of Optex Optimization Expert System. We can affirm that Optex Quantum AI is the state-of-the-art of optimization. The reasons are: generative artificial intelligence to produce the codes of the algorithms without programmers, and access to the world's fastest algorithms. Duration. The total duration of the course is 50 hours of training, divided into at least 25 virtual sessions of 2 hours each. The course is designed for the student to take one class, one virtual session, each week. However, the speed at which the course is taken depends on the student. Virtual face-to-face classes are held to clarify doubts and research topics. Course, Parallel and Distributed Optimization. The table presents the summary of the course topic plan, which is divided into two main topic groups. A total of 25 sessions are planned. The course director is the founder and scientific director of R-CADT. Engineer Velázquez Bermudez's experience in applied mathematical programming dates back to 1972, which means that he has accumulated 50 years solving real-world problems doing engineering consulting using mathematical models. On the specific topic of large-scale optimization, his advanced expertise began in 1978, when he first implemented the Bender's partitioning method. From that moment to date, part of his research is related to the creation of algorithms aimed at atomized optimization of problems, the latest being the multi-Bender's decomposition algorithm, created in 2022, to work with the artificial hypothalamus. R-CADT is the most applied academic center in the integration of the teaching of mathematical programming and artificial intelligence. For more information you can consult the URL. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.